Hello guys, this is Siv and today we will discuss about structure, that is how we can assign dynamic memory to the structure pointer variable, and what is the concept of dangling pointer. So first we will make a program, and after that with the help of output of that program we will understand this concept. So let's start. We will give our program name mm-3.c, and now we will give our program name some comment. So this is third program under memory management, and we will talk about structure and dangling pointer. Dangling pointer. So we will write has include stdio.h has include stdlib.h and void main. So this is our basic structure of the program, and now we will make a structure. So we will write struct keyword, and structure name will be employee, employee, employee. Now we will write members of the employee structure. So first member will be data member will be int emp_code. Second will be data member character emp_name, name, and it is array type. We will give here 50 byte, and second will be character emp_n last. We will also give it 50. First it is a first name, and this is employee, and last means last name. Okay, this is my naming convention. You can use accordingly whatever you think right. So next is float emp salary. It is float type. So these are the members of our structure employee. So in GCC compiler it will take 4 byte, it will take 50 byte. In memory it will take also 50 byte, and this will take 4 byte in GCC compiler. I will show you in output also. And now we will write type def struct employee and emp. So here we use type depth for this whole structure and structure variable name. So in our program for this whole struct employee we will use only this emp. It will denote this whole line struct employee. So this is the shortcut given by the GCC compiler or any other compiler you can use. So now we will come in our main program. In our main program, first we will make a structure variable. So we will write emp in small letter. Second, we will make a structure pointer variable. So we will write emp pointer emp underscore ptr. This is a pointer type of structure variable emp ptr. Okay, now we will write int n comma I. Now we will give here some printf. So printf new line, and we will give here a heading emp member size. Emp member size. I will print size of the members, data members of the structure variable, or we can say structure, employee structure. I need to print all the member size, data member size. So we will write here again, just we need to copy this and here we will write size of emp underscore code, size of emp underscore code, and we'll write percentage lu unsigned integer byte, and here we will give write size of, and size of is this. Copy this and paste here emp code. Similarly we need to do for other members also, so we will copy it and paste. Here we will write size of emp name. Okay, and we will write same here emp name. One mistake we did here, we need to call these data members with the variable of the structure, that is emp. Without it, it will give some error. So we will write emp. Okay, now for next variable, size of emp enlarged. So we will write here emp dot, just let me copy it. Okay, and at the last we forgot something. Yes, at the last we have salary also, so let me copy this. Size of emp salary, SALARY, ry salary, same we will pass here. Salary. Okay guys, so we have now 4 data members of employee structure, and now we need to calculate the total also, total size. So one more printf we need here. Okay, and size of emp we will write, size of emp, and we will directly here write emp. It will calculate the size automatically, emp. Okay, that's fine. And now we will give one more printf for taking the value from the user to dynamically assign the memory to the structure pointer. So first let me write here emp underscore ptr equal malloc. Okay guys, and here we will write n multiply by size of structure employee. Okay, and here we will do type casting of structure type emp star. Okay, now we will take this n dynamically from the user when program will run. So just we need to pass here one heading. So let me do like this, new line. Okay, and we will write, okay, this is not needed, directly we can write enter the number of employees to be added, enter the number of employees to be added. Okay, and we will write here scanf percentage d and ampersand n. So whatever number of employees user will enter here, Calloc will dynamically allocate the memory to the structure pointer. Okay, so after this we need to handle the exception also. So if emp ptr equal to null. Okay, so we will write a message. So just we need to copy one printf and write here memory allocation failed. Okay, let me write it in small. Memory allocation is failed. Okay, and exit with 0, else in else part we will write success message. So bracket is not required because we are printing only one line, so at that time we can skip the brackets. So directly we will write memory allocation is successful. Okay guys, and now we will print the address. Whatever dynamically memory is allocated, we will print that address along with index of that memory location. So we will use here one for loop, and it will be I equal to 0, I less than n, and I plus plus. And after this we will write printf new line address of empptr, address of emp underscore ptr. We will pass here %d is %p for address. So we will write here double quotes, so it is for indexing I, and ampersand emp underscore ptr. Here we will pass I. So index and their memory location will print 1 to 1. Okay, so next we need another printf, so we will copy this, paste here, and here we will print the size of empptr in byte, means how much size this memory location contain. So we will write here size of empptr, size of emp underscore ptr %d is colon %lu byte, because size will be in byte, memory size. Okay, so I will be here for indexing, and here we will use size of method, size of okay, that's fine. Now we will take some scanf for the number of employees which user want to add. So for this we need one for loop, and here I equal to 0, I less than n, I plus plus. Okay, and here we will give some heading, enter employee detail. So we need printf and write enter emp detail. Okay, we will write another printf and will pass message enter the employee code. Enter the employee code. And we can remove the new line here. After this, scanf and we will write %d ampersand emp underscore ptr. We will write here I and dot emp code means structure data member. We will pass underscore code cod. Similarly we will do for other members also, so we need to copy these two lines and paste here. Now we will ask enter employee first name. Enter employee first name. So here we will write emp name. We can skip ampersand because it is a string, so for string we can skip it. Third, it is third. Enter employee last name. Okay, and we will write n last, skip the ampersand and write here s. Last one, salary. So enter the employee salary. Okay, and here will be salary. Salary means structure data member. Salary we will call here. So it was a float, so we will pass here f. That's fine. Now we need to display this information also, so we will give some printf. Whatever information we have given, we need to display also. So we write n, give a heading added employee, added emp. Okay, now we will use here for loop. I equal 0, I less than n, I plus plus. So here we will write a printf and will give a dash line to differentiate one record from another. Now we will write here a printf new line and address of emp. First, what will we print here? We print address of the whatever pointer will dynamically will get the address from the malloc. First we will print that address. After that, size of that memory address, and after that we will print the record. So we will write here address of emp, address of emp at emp underscore ptr. We will pass here %d and is colon %p, and here we will pass I for index, and for address we will write ampersand emp underscore ptr, and will pass I. So we will copy this printf, paste in next line, and now we will write here another message. Size of emp ptr %d is colon %lu byte. It will be in byte. Okay, so for index I will work here, and here we will write size of sizeof, size of method, and here there will not e, only ptr will be used. Okay, so now we will use another printf, and will change the heading here, or we can say message. We will write emp code and colon %t. Okay, and for emp code to print, we need to call the emp pointer. So we will write emp underscore ptr indexing I dot. We will call the structure data member, that is emp underscore code. We need to copy this printf and paste emp name. So here first name and last name both we will print, so we will use %s and ptri. First we will write emp name comma, we need to copy this, paste, and emp and last we will write like this. Okay, that's fine. Now one more printf for salary, so we need to copy this printf, paste here, on emp salary. We will write emp salary Okay, and here we will write EMP salary. So our detail is completed. Now we need to give one printf for a space, new line. Now we will free the structure pointer variable to deallocate the memory assigned by the malloc. emp underscore ptr. So what happened after deallocating the memory with the free method? Still structure pointer will denote the address, starting address allocating by the malloc. So this is where dangling pointer concept came. So after free we need to give some null value to emp pointer. Here actually we are using a structure, so we are talking for structure, but for any other variable also, like integer pointer or a character pointer also, we will use the same concept. So to visualize this issue, we will give here some printf and new line, and here we will pass a heading after free. Okay, yes, new line, and here we will pass the address stored in the emp pointer after free. So we will write printf new line and address store at emp ptr at index 0 after free. Is percentage %p we will use for address. Okay guys, so we will write here ampersand emp underscore ptr. We will pass here 0. So to handle the dangling pointer so that it should not point to the address after deallocation, we will write here a line emp underscore ptr and will assign it to null. Now it will denote after deallocation of the memory, it will point to the null pointer, or we can say it will point to the null value. So we will copy these two lines and paste this message here to visualize the result in the output of the program. So we will write after null, so it will print the value. So guys, I think our program is completed. Just we need to compile and see the output. So let me save it and just see the result. So gcc mm-3 .c space -o mm-3. So there is some error, let me check. Okay, some semicolon we have missed here, so let me go. Okay, here in type def, here we will use semicolon, I think. Let me check. Okay, and one more semicolon will be here. Now save and compile again. Okay, few more errors are there, let me check. Okay, some mistakes are there, let me fix. Okay, here some error is there and other error are okay, here name is wrong, this is a ptr, we need to remove e. This is the result of copy and paste, so we should always write code on self. I think now it is correct, let me check. Save. Okay, where is the error? Else part. Okay, okay, few errors are there, let me fix. Sorry guys, because in our program there are lots of errors, so wait. In detail we will write here f, and in else part it was also showing some error. Else is okay, print. Okay, let me compile again. One error only. Okay, let me check. Okay, we need to add semicolon here. And now I think it is completed. Yes, all errors gone. Now we are ready to analyze the result of our program. Compile and run mm-3. So guys, you can see whatever data members structure contain employee code, it is 4 byte, employee name 50 byte, employee and last, that is last name 50 byte, and employee salary 4 byte. Total is 108 byte. Structure size is this, employee structure size. Now it is asking enter the number of employees to be added. So suppose that I entered 2. Okay, and I hit enter, and it is not E2, it is 2 only. You can see it is 2. Okay, I hit the enter. Now detail will come. You can see we were here. After entering 2, memory allocation is successful. And here what memory we got at a emp pointer 0, memory is this, and size of this memory is 108 byte, that is one structure. Employee structure size we got, and another memory address is this at size 108 byte. We can check. Now it is asking enter emp detail. So enter the MP code. So MP code is suppose that dummy I'm just entering 01, hit enter. Enter the employee first name, I am entering Shiv, last name Kumar, salary it is some dummy 50. Okay, now it is asking second detail, so I'm entering 02. Employee first name Manoj, last name Pandey, salary 70, enter. So all detail will come. After entering all the details, enter employee details 70, we will get this added EMP. So what we added at this location, structure size is 108 byte, employee code is 1, name Shiv Kumar, salary 50,000, and second detail at this address, structure size is 108 byte, employee code is 2, name Manoj Pandey, salary 70,000. So after free, as I told you in the code, after deallocation of the memory, still our EMP pointer denoting this address, giving the reference of this address, but it is no more available for this structure pointer. So that's why this is the issue of the dangling pointer. It is known as dangling pointer. So after assigning the null, now EMP structure pointer and denoting the null value. So by this we can solve the issue of the dangling pointer. So guys, in this program we have known how we can dynamically assign the memory to the structure pointer variable, and how we can handle the situation of the dangling pointer, how we can face the dangling pointer issue, or we can say how we can solve the dangling pointer issue. So guys, I think you got the idea. So thank you so much. Bye bye.